Hello there! I hope you're having an amazing day and that you're feeling ready to be literal. And when I say literal, I actually mean ready to talk about number literals. Our question of the day is of course going to be, what are number literals? So, number literals are these things that we use to add to our variables in order to extend some information about our variables in form of prefixes and suffixes. Everything is crystal clear right now, right? It's not a very good explanation, I'm aware of that. So I think the best way to do this is to go straight to Visual Studio Code and see it in practice. Welcome, my dear friends, to the promised land. This is the land where programmers live in peace and harmony. Of course, I'm talking about Visual Studio Code environment. Today, we will be talking about some basics about number literals in Rust. I hope you're feeling excited and eager to master them. Breaking news! Before we talk about number literals in Visual Studio Code, my dear viewers, we need to cover them in theory here. Joking aside, what can we use number literals for? So we can use them to actually specify the data type of our variable without specifying it explicitly. So without using explicit data type notation that we covered in one of the previous videos, or you can use them to specify the number system that you want to be using for your value that is stored inside of the variable. So basically you can specify which transformation should be used for the value that you put inside of your variable. And here we have a few options. Or finally, we can use a literal to make our numbers much more readable. Okay, we can get started with discussion about data type literals. And the story here is pretty straightforward. So you can basically add a suffix to our value of the variable, and that suffix is going to contain the actual data type of the variable that we want to be using. Of course, this works for both signed and unsigned integers and all the versions of floating point numbers. So you can basically specify the data type of your numbers without using explicit data type notation. The compiler is going to figure out what we want to be using. We can also use number literals to specify the number system that we want to be using on the value that is stored inside of our variable. So you can use one of the prefixes that we'll cover in the next video, and that way specify to our compiler just so it knows which number system it should convert the number we have specified into. But as I stated, more on this topic in the next video. And finally, we can use literals as separators to make our numbers much more easier to read. And here the situation might not be so intuitive at first glance, because this is not such a common functionality in other programming languages, at least from my experience. And when you see this in practice, you will probably see the benefits that this functionality is giving us, because they are good in certain situations. If you do not trust me, see for yourself. Oh my god, what was that? I hate this breaking news. They just keep interrupting us and preventing us from spending some quality time in our Visual Studio Code environment. Okay, now we can finally spend some quality time alone with our Visual Studio Code. We have our project ready and waiting for us, And inside of it you can already see that I have prepared some code. And this code is basically meant to prevent me from bothering you while I type all of these examples and trying to figure out what might be a good idea to talk about and to show what number literals are all about. Of course, the first variable is just going to be a warm-up, so we do not have any number literals specified on it. And as you can see, we just assigned 123 as a value to this variable. And when I save the file, you will see that our compiler is going to infer the type for this variable. And if you remember from the previous discussions from previous videos, you know that the default type for integral numbers is going to be i32. So basically 32-bit version of signed integer data type. Okay, what about our second variable? As you can see, we have the same number, 123, assigned to this variable, but after 123 you can see i16. And when I save the file, you can see that compiler has inferred the type i16, not i32, which is the default integral data type that our compiler is going to infer for integral numbers. Apparently, our compiler can figure out that we appended this suffix to our variable value, and it figured out that we want to assign a new data type which is different from the default one. Of course, we can do exactly the same thing with unsigned integer data type. Let's use the same value, so 123, but after it we're going to add u32 as a data type. And when I save the file, you can see that the compiler has, as expected, provided us with inferred data type of u32, which means that everything is working as expected. Now, I want to show you that our compiler is extremely smart even in these situations. So, for our fourth variable, I'm going to assign 256 as a value, and I'm going to append u8 as a data type. And when I save the file, you will see red squiggly line under the value 256. And if you think about it, that means that our compiler has figured out that we want to assign data type u8 to this variable, and the range of valid values for u8 data type is, if you remember, from 0 to 255. And we have assigned 256 to this variable, which is out of the range for u8 data type. And the compiler has figured this all out for us and is warning us with an error message that we made a mistake. You have to agree, the compiler is awesome. Also, have in mind that we can use, in my personal opinion, a much cleaner way to specify the data type, and that is to add the value and then use underscore and then append the value for our data type. So let us use this in example. For our fifth variable, we're going to again assign 123 as a value, but we are going to follow it up with underscore, and then we are going to add i128, for example. And when I save the file, you can see that the compiler has inferred perfectly fine that our data type is i128, which means that this is a completely valid way to specify your data type. But we are still not done here. We need to talk about floating point numbers. And to do that, let's create our floating point variable and assign some value to it and follow it up with underscore and then f32. And when I save the file, you can see that inferred type is f32. And if you remember from our discussion about floating point numbers, the default data type for floating point numbers is f64. So right here we have a live example that we managed to override the default behavior, and we assigned f32 as a data type to this variable, which means our mission was a successful one. And right now, my dear friend, we are done with our discussion about number literals regarding data types. We can now jump to our second topic of the day. But as I already mentioned, we are going to skip the second topic of the day when it comes to number literals because it's regarding number systems, and we are going to dedicate our next video to this topic, so we can skip right ahead to the third topic. And the third topic is going to be regarding number separators. And the story here is extremely simple. You can see that I already created some variable and assigned a huge number to it. It's a billion basically, but let's say a huge number, it sounds more tempting that way. And when I try to figure out how many zeros we have here, I'm definitely going to have a hard time to do that. I'll basically have to use my cursor and to go 1 0 at a time to try to count them all. So when we include number literals and exactly the same number, so still a billion, we are going to see that we have no struggle whatsoever to read the number. We can basically just jump through it and see that we have 9 zeros followed by 1. So it's way easier to read the number and count digits when we are using this underscore character. I told you, it's a very simple thing to use and it can help you out a lot in certain situations. So I think this is a very beneficial lesson because we learned a few very important things and very beneficial things that are going to make our lives much easier, but we do not have to go through a lot of struggle to figure them out. I hope that you agree with me here. I mean, of course, if you have any questions or concerns, please leave a comment down under this video. And this, my friend, was everything I wanted to share in this video. Do not get me wrong, we still got a lot of stuff to cover in our future video, but also we have to be aware of the fact that right now we can use number literals to specify the data type of our variables without using explicit notation, and we can also use them as separators to make our numbers much more humanly readable, which is great, and it will make our lives a lot easier. I hope that you enjoyed this video and found it useful, and if you did, I would like to kindly ask you to subscribe to this channel and like this video, because it would help both me and the channel grow and share this knowledge with the rest of the community. So I would like to thank you in advance for doing that. And as you already know probably, in our next video we will be continuing our discussion about number literals, but with the focus on number systems. So stay tuned for that. So there is only one thing left, and that is for me to wish you an amazing day. Goodbye!